Hi, can you hear me? Hello,
Hello,
can you hear me?
I can. How are you?
Good, how are you?
Good. I'm trying to send
Good,
out a message to the rest of the class just
okay,
in case somebody else wants to join us.
okay,
So I'm a little distracted. So just a second.
no worries.
For some reason, I can't type and talk at the same time these days. So post it in a couple sites. There we go. Almost done. And you know why this link that I created an hour ago wasn't working? I have no idea.
Yeah, I
But
tried that one. I don't
there
know
you go.
either.
You know, who knows?
It's crazy, technology.
Okay, so you had a question about blood typing under the
Yes,
genetics information. So,
yes.
what is really strange about blood typing? Oh, I lost my page I saved. Let's see, where did I put it? Okay. Um, you may have been taught that blood typing happens using a, a, um, a chart, something like this. And if that's the case, then our question that's posed, if one parent has type A and one parent has type B, then all four of those choices are correct. However, it's a little more complicated than that. Well, this is true, that it's a possibility that the child could have any of these four blood types. Because mom has A and dad has B, whoops, mom has A and dad has B, then what you have to do is you have to cross off all the things that have one A or one B in them,
Okay.
and you end up with O.
So why would you cross out them again?
So it goes back to how the genes are dominant or recessive.
Oh,
And when we do
okay,
blood types, what we're doing is in order to have a type A blood type, you have to have two alleles that are type A. Okay, but if
right.
mom is type
Okay,
B and dad's type A, then we only have one of each.
right. Because for those, they're heterozygous.
Right.
Okay, yes, that makes sense.
So that's why this is included in this lecture too, because it has to do with the blood typing and the genetics um, and the allele placement and all of that. So
Okay.
um, both of my parents are type O, so I'm type O. That's pretty easy. But once you start mixing it up, it can be more difficult, definitely.
Yes, I was getting confused on this one. I don't know why. I just kept thinking it was type AB because A and B, but that still would be heterozygous, right? Because it's
Right,
AB.
right.
But yeah, so that makes
So,
total sense now.
right. So the people who get type AB blood, um, they're getting one allele from one parent and one allele from another parent, right?
Right.
Or they're getting two alleles for AB, because if both parents have AB, they could still end up with AB blood type or A or B. And that's because it depends on how many alleles are actually coming through. And just like the diagram that's shown here, not everyone's going to get a disease. Not everyone's going to receive the same allele pattern, even if they're all your children.
Okay. So if the question were to be, instead of a white square or circle, like the black square circle, would it still be type O?
We would need more information.
Okay.
So
Okay.
this question doesn't give us enough information other than to exclude the first three choices. So we'd need more information before we could decide
Okay.
what the dark colored boxes are.
Okay, that makes sense.
Okay.
I think that's all I had.
Well, goodness, that's no fun. So is everything else seems like it's going okay? You're not having
Yeah,
the schedule?
I think so. Yes, it does. And the mini lectures are really helpful, I think.
Okay.
For everything. I guess I did have a question, but we kind of covered it over class, just the difference between penetrance and expressivity. But
you want to cover it more?
I think I'm good. I think that we have it. It's just the ratio of how many people with the phenotype have the genotype, right, for penetrance.
Right, and so it is the ratio of how many people, so it's how strong to think of it in layman's terms, it's how strongly it becomes expressed. So if we pulled a group of 100 people randomly out of a community, and we'd see how many people in that group would have those genetic markers. And that's, helps us to see how strong. That's how they can say, like, oh, 1 in 10,000 births, or, to give you kind of an estimate of what might occur.
Right. Okay. That makes sense. Right. Hi.
Hi.
Yeah, I just figured I'd pop on for support in case people had questions about like group activities and stuff.
Okay. We were just talking and actually Megan asked one question and she thinks she's done. So
awesome.
I'm cool with that.
Yes.
That's good news. And then I think I had a student who said they won't be able to join, but we'll share our recording so that they can get that information. So,
sweet. Well, thank you so much.
Yeah. Thanks for popping in, Megan. And
yes.
You have a good afternoon.
You too.
Okay.
See you later.
All right. Bye-bye.
Bye.